Hello, I'm Mr. McBrien. This is TJ20 Arduino Inputs. The Ontario curriculum has us making sure that we can develop programs that interact with an external device. We're going to use input statements, output statements, and of course repetitions, structures. Today, though, we're going to focus on a specific aspect of those devices. So what we want to talk about is the fact that there are very few devices that don't interact with their environment. If you wish, feel free to pause the movie and try to think of devices that don't actually interact with the outside world. Ones that do the same thing over and over again with no decision-making systems, no sensors, for example. And I think you'd be hard-pressed to find any even moderately sophisticated devices that work independently. In fact, most devices adapt to their environment in some way, especially if we're willing to extend that idea of adapting to your environment in some ways we'll talk about here. So what we want to be able to do in computer engineering is have our circuits make some kind of choice. So we've seen already that our microprocessor can execute commands in a loop. Well, what we can do is we can change that loop a little bit and incorporate steps of monitoring the environment, the outside environment. And what this does is allows us to make our programs change their behavior based on what they sense. And sometimes that change in behavior will be simple. Go into standby mode. But really, it can be incredibly complicated if we need it to be. Okay, first, an example of a very simple interactive system. We can have a system that monitors a switch and checks to see if that switch has been pressed. And if it hasn't, it simply goes ahead and continues in a monitoring loop, just checking each time to see if that switch has been pressed. And then, of course, eventually we expect that that switch will be pressed. And when it is, we can start some kind of function, some different behavior. So that's about as simple an interactive system as I can conceive. But we can have far more sophisticated sensing processes than just a switch. So yes, we can have users interact with the device in many different ways. We can interact with the internet. But particularly interesting is this idea of interacting with sensors. Other devices are available, and we'll talk about a few of these as well. Okay, so user inputs. We can connect hardware to the Arduino to make it possible for a user to change its behavior in a bunch of different ways. We already talked about switches, but we can connect up dials. We can connect up keypads, touch screens, and more. So some examples of applications of this idea. We're going to return to this one in a few minutes. A user presses a switch, power is provided to a circuit until the switch is pressed again, essentially a toggle switch. An interesting one. A user types in a passcode in a keypad, and this disables a security system so the user can go through a doorway. So what about sensors? We have lots of options for Arduino monitoring sensors, much like the Arduino monitors a switch. Sensors, really, we could spend a great deal of time talking about sensors. There are many industries that are built simply around the idea of sensors, and in fact some very sophisticated sensors have been put in place. But a sensor at its core is just something that changes its electrical behavior in response to a specific stimulus from the environment. So we have available to us sensors that can detect light or the lack of same, sensors that detect infrared, moisture, heat or the lack of heat, sound, and much, much more. Okay, some examples of some applications of this. We'll examine this night light concept in a bit more detail in a few minutes, and in fact, of course, we talked about it for our circuits. But we can design an Arduino-based reaction to a light system. If there's little or no light hitting a light-dependent resistor, an LDR, we can trigger a decision-making system on that basis. But we can make something far more sophisticated. An IR sensor could detect a pattern of pulses and provide power to a device, for example. As far as internet input goes, there are multiple available Arduino shields that include Wi-Fi and or Ethernet access. And on that basis, Arduinos can be controlled by an app. Or, if we want to get more sophisticated, an Arduino can do something like monitor a website like Twitter. So some examples of applications: an iPhone app sends commands to an Arduino controlling a thermostat. Or an Arduino monitors a website and sounds a siren whenever the Leafs score. By the way, if you're a Habs fan, that also could work out. Okay, other devices. We can connect other devices to the Arduino, provided they have an output that we can use. So virtually any kind of electrical output can be, with or without some modification, used with the Arduino. There's a Bluetooth shield, and we can design our own IR remote system using some sensors, or there is also a shield for the Arduino for IR. Really, whether we use a shield depends on the situation and how clever we are. Some other examples of fun applications. Well, here's a good one. So a romantic geek connects a lockbox to an Arduino with a GPS shield, and he gives a lockbox to a woman, presumably one he knows, with a series of clues. And when she gets to the location described in the clues, the lockbox automatically opens to reveal the engagement ring that he's put inside. So we want to dig into how the Arduino uses inputs. Obviously, the way we do this depends on the type of input, but usually we're going to incorporate a status check in a loop. And the checks are coded dependent on the sensor and the situation. So I alluded to this earlier. We can rebuild our nightlight application. And we do this simply by looking at the resistance of a circuit. Now, as we discussed previously, the resistance of an LDR changes when light hits it. And Arduino wants to access this. Well, there is a catch to this part, and that is an Arduino doesn't have an ohm meter in it. Measuring resistance, we do that indirectly. So we measure the resistance by running 5 volts across the LDR plus another resistor. And some of us remember voltage drop from the earlier circuits unit. So the current that's running through the LDR will create a voltage drop between it and the resistor. And so what we can do is we can measure the voltage after the resistor and just back calculate the current from there. So this is the kind of circuit we would set up. So we'd have a ground, run a fixed resistor, then connect to the AO, then have our photocell and connect up to the 5 volts. And then from there we can just simply do the math to calculate the resistance of the photocell. Okay, and we don't want to get into this in too much detail, but based on the resistance, we can calculate the light level and then make a decision on that basis. So I'm going to bounce through this piece. In fact, you can implement this later if you want to. But it is useful to look at the reading of the voltage from these lines. Okay, and if you do want to follow this code along, you can simply read the voltage or write the voltage to the serial monitor, and you can have a look at it. And this is a good step to take. I've mentioned this before. In any development, it's a good idea to include these kind of serial monitor processes. So this is, in any case, how we read in our voltage from a given pin. Okay, I'd like us to create a simpler implementation as a first pass, since we've got a number of concepts that we're going to incorporate into this early implementation. So I alluded to this widget earlier. I'd like you to implement a push button LED switch that's essentially a toggle. So the Arduino monitors a button to see if it's pushed. If it is, it turns on the LED. Once the LED is lit, the behavior changes. So we monitor the button to see if it's pushed in order to turn the LED off. And one little hint when you're implementing this, don't forget to insert a delay between your monitoring steps, or you can have issues with confusion where while the button is being pushed down, it registers more than once. But in order to implement the logic that we're talking about there, in addition to having a monitoring step inside our loop, we are going to need another tool, and that is what amounts to if-then statements. But in Arduino, we would be more likely to say if, else, else if. By the way, some of the concepts here are pulled from the Arduino Classroom Chapter 4a. I'd encourage you to have a look at that if you need any help with any of these pieces. Okay, so here is code that will stand in nicely for our monitoring the state of our push button. So we need to actually go ahead and read the state of the push button, and we do it by assigning this variable from that read command. And then from there we need this idea of an if statement and the instruction to do something inside the parentheses, and then an else statement to have it do something else if that statement is not true. And it'll look something like this. If the push button state is high, then we want to turn on the LED. Else, if since we only have two options, if the push button state isn't high, it must be low. We turn the LED off. So what we'll need to do is we will look at first this idea of the state of a given push button. So we'll read the push button from a given pin, and then assign a push button state based on that, either high or low. And then we'll apply this new logic, this idea of if a given statement is true, do this, else do that. And I'd like you to, rather than just use this simple logic that I show here, I'd like you to use the syntax and apply the logic that I described previously. So at the Arduino classroom, they did, if the push button state is high, turn the LED on, or if the push button state isn't high, by inference we can say that it must be low, and we'll turn the LED off. Well, that's fine. So what they're really saying is they're matching it to a switch, which of course there's much easier ways to do that. What I'd like you to do instead is use the switch as a toggle. So if the switch is touched once, it turns the LED on, and the LED stays on until the switch is tapped a second time, in which case it turns the LED to low. So you'll need a slightly different logic than they have here. And when you think about it, it's a much more interesting logic, because really the other logic could be achieved through a simple switch. Now, if you don't have a push button handy, no big deal. You can get the same result as a push button by just touching two leads together, two jumpers together. And the Arduino will see that as a switch. Okay, so if you had an easy time with that activity, and probably you did, there is an extension activity you can work on, building an electronic thermometer from your Arduino. What we can do is we can configure it to monitor a temperature sensor and change its behavior based on the result from the temperature sensor. So for starters, of course, we'll use the serial monitor as we usually do when we're doing development, and report the temperature to there. And for the math reference, you can have a look at the TMP35 temperature sensor datasheet to see the math that you'll use in order to report that temperature to the serial monitor. And if you're feeling spiffy, you can go ahead and breadboard up a quick read thermometer for 20 experience points. It's essentially the same thing, but instead of sending the answers about temperature to the serial monitor, we make some simple decisions based on the temperature and then change the output of the thermometer. So we'll configure the Arduino based on the Celsius temperature, make it red if the temperature is greater than 27 degrees, yellow at 24, and green if it's less than 21, which isn't terribly likely in this classroom. Okay, so go ahead and breadboard that up and show me when you've got it running. For your homework, please upload the code for the LED switches, which is the activity for today. Thanks very much, and have yourself a great day.